All right then, so here we are in question 1. We've got to solve this inequality. 3x squared minus 12x plus 16 is greater than 3x plus 4. Well, we just got to rearrange this. We're going to subtract 3x from both sides. We get 3x squared minus 15x. And we're going to subtract 4 from both sides. So that's going to be plus 12 is greater than 0. Now, we can simplify this, can't we? We can divide everything through by 3. So we're going to get x squared minus 5x plus 4 is greater than 0. Now, it may seem a bit overkill, but I often find that students end up getting this wrong because they don't sketch out a graph. I think sketching the graph is by far the best way to kind of confirm that you've got the right answers. So that's the way I'm going to do it. So what I'm going to try to do is I'm going to sketch this quadratic here. Do that, I'm going to use the x-intercepts. And to get the x-intercepts, I'm going to have to factorize. So if I factorize this quadratic, I'm going to get... I need two numbers. They're going to multiply together to give positive 4, and then they're going to add together to give negative 5. Well, those two numbers are going to be negative 1 and negative 4. Okay, so my x-intercepts for this quadratic will be 1 and 4. So what I'm going to do is I'm going to draw that on the graph. So let's draw a nice graph there, like that. Ooh, sorry. Okay. And we've got x-coordinate here of 1 and x-coordinate here of 4. And so our quadratic is going to look something like this. Sorry about it being a bit rough. Never mind, something like that. Okay, like that. So that's our quadratic. Now, what do we want? We want this quadratic to be greater than or equal to 0, right? So we want the y values, basically, of this quadratic to be greater than 0. Now, where is that the case? Well, it's the case here. Here, the quadratic is greater than 0 because the y values are bigger than 0. And here, the quadratic is also bigger than 0 because the y values are greater than 0. Okay, so we're looking at this particular region here, right? That region and that region. Well, then we've got to ask ourselves the question, well, which values of x give us that region of our quadratic? Well, there are two regions, aren't there? We've got everything that's greater than 4. So we need x to be greater than 4. And we also need everything to be less than 1. So we require that x is less than 1. Okay, so that's the solution to this particular inequality. We require that x is less than 1 and x is greater than 4. Guys, I'm sure that some of you can do this faster. You don't need to draw the graph. Okay, that's fine. But generally speaking, the big mistake I always see with my students is they get to this point of factorizing. They don't know what to do. And so then they create the solution that x is greater than 1 and x is greater than 4. Or in other words, they have got the sign on one of these inequalities wrong. Please don't do that, right? If you need to do a little bit of extra work in order to get the right answer, then do a little bit of extra work. Also, if you draw a graph, it helps you to see why this thing is working. You can see that the quadratic is greater than 0 for certain values of x. So I think that's a helpful thing. All right, let's go to part B. All right, we've got 3x squared minus 12x plus 6. Well, we want to write it in the form, the completed square form, basically. So what am I going to do? Well, I'm going to take the coefficient of x squared, and I'm going to factorize it out. I'm going to get 3 bracket x squared minus 4x, close bracket, plus 16. Okay, I don't have to factorize out the 16, right? Because it's irrelevant when we come to completing the square. And then if I complete the square, I'm going to write this thing. So just let me explain. We always take the coefficient of x, in this case, negative 4. We halve it. We get negative 2. We stick it there. And then we subtract off that same thing squared. Okay, so let me just elaborate that. Take the coefficient of x, negative 4. Halve it, get negative 2, stick it here. And then subtract off the same thing squared. That's how you complete the square. We've got to add 16. All right, let's just expand this. We're going to end up with 3 bracket x minus 2 all squared. Negative 2 squared is positive 4. So we've got 3 times by minus 4, which is minus 12, plus 16. And so here we end up with 3 bracket x minus 2 squared minus 12 plus 16 is plus 4. So that's how we've completed the square. In other words, our a value is 3, our b value is negative 2 in this case, and our c value is 4. All right, then, the last part of this question, hence, right? If you see the word hence, that means you need to use the previous part of the question to answer. So hence, write down means there's only going to be worth 1 mark, right? So you don't have to do any working. It should be obvious. the equation of the tangent to the curve 3x squared minus 12x plus 16 at the minimum point of the curve. Now look guys, sometimes these 1-mark questions are actually really killer, and what they're testing is whether or not you understand it. Okay, well, let's see what the sketch of our curve is going to look like. If I was to draw a minimum point, right, so here's a quadratic, or just a random quadratic. The minimum point is here. Okay, what would the tangent look like at that particular point? Well, the tangent is going to be a horizontal line, isn't it? It's going to be a horizontal line like that. Okay, and what would be the equation of the horizontal line? Well, it would be y is equal to whatever this particular y coordinate is here, right? So if we want the equation of a horizontal line, it's y is equal to whatever, 2, or y is equal to 3, or y is equal to 4. Gives you a horizontal line that goes through that y coordinate. So we just go back up to our completed square form. What we know is that we have got a turning point, or a vertex. We have got a vertex at the coordinate 2, 4, right? The reason it's 2 is because it's there, and the y coordinate is 4 is there. So if we were to have our graph, we were to draw on our axes, okay, basically what we're saying is the quadratic is going to look something like this. Right? The x coordinate of our turning point is going to be 2, and the y coordinate is going to be 4. And so therefore, the equation of the tangent is just the line y is equal to 4. Okay? So it's only worth 1 mark, because in a way you could just state it, but my guess is actually quite a lot of students are going to find that quite difficult, because they're not even going to understand the question in the first place. So I've tried to explain it, taken a bit of time. I hope that was helpful. Okay, then question 2, which is a differentiation style question. We've got a curve with equation 32x squared plus 1 upon 8x squared. I want to find the coordinates of the stationary points of the curve. All right, well, we just need to know what is the definition of a stationary point. A stationary point is where the gradient is 0, and the gradient is given by dy dx. So a stationary point is where dy dx is equal to 0, or y prime is equal to 0. That is the basic definition. That's something you should be hopefully familiar with, but it's really important to state it up front. So what we need to do is we then need to differentiate this thing, and then set our derivative equal to 0. So how are we going to differentiate? Well, first thing, we need to write everything in indices form. Now, I'm going to do that nice and carefully. So we're going to have y is equal to 32x squared. Now, I'm going to split this up a little bit. I'm going to write this as 1 upon 8 times by 1 upon x squared. So I hope that you can see that this thing that I've written is actually the same thing as that. Right, why have I done that? Well, because I can write the 1 upon x squared as being x to the power of -2. I can use my indices rules, because I can say that a to the power of -n is equal to 1 upon a to the n, right? And I've split it up because one of the common things I see students do is they get a little bit uncertain when you've got a number on the denominator. And so often what happens is I end up with something like 8x to the -2. Because students get confused. So I think if you split it up at the beginning, it makes it easier for you to process. All right, well, now that we've done that, we can actually differentiate. So if we differentiate, we bring the 2 down to the front, we get 64x. We differentiate the 8x to the power of -2, then we're going to get -1/4 x to the power of -3. And having differentiated, I think at that point it is helpful just to convert back from indices form. So I'm going to rewrite this as 1 upon x to the power of 3. Okay, basically you convert to indices form if you want to differentiate, because you need everything in terms of powers. But once you've differentiated, you want to go back really, because otherwise it's going to make your algebra hard. Okay, now then, we're going to state the following. Stationary point when y prime is equal to 0. We want to explain to the examiner very clearly that we know what we're doing. And so therefore 0 is equal to 64x minus 1 upon 4x cubed. Okay. All right, then I will I'll divide this whole thing through. Sorry, what will I do? I will multiply everything through by 4x cubed. I think it's probably the easiest thing. So on the left-hand side, if I multiply by 4x cubed, I still get 0. On the right-hand side, if I get 64x times by 4x cubed, or 64 times by 4 is 256. So This is 256x to the power of 4 minus 1. So therefore, x to the power of 4 is going to equal to 1 over 256. And so then what I've got to do is I've got to find the fourth root of 256, or 1 upon 256, beg your pardon. And that's the same as square rooting, and then square rooting again. What I should end up with is plus or minus a quarter. Okay, now let's just check our question. I want to find the coordinates, right? Coordinates in plural. So how are we going to do that? Well, we've got to make sure we substitute and find our y values. So remembering that y is equal to, what was y equal to? 32x squared plus 1 upon 8x squared. So 32x squared plus 1 upon 8x squared, I believe. Yeah. So if we substitute in x is equal to a quarter, so when x is equal to 1 upon 4, then y is going to be equal to 32 times by a quarter squared, which is 1 upon 16, plus 1 upon 8 times by, again, a quarter squared, which is 1 upon 16 on the bottom. So 32 divided by 16 is 2, plus 1 over a half, okay, because 8 times the 16th is a half. And 1 divided by a half is just 2, so we end up with 2 plus 2, which is 4. So we've got a coordinate here, which is a quarter, comma, 4. And then if we're substituting in x is equal to negative a quarter, so when x is equal to negative a quarter, well, actually, we really don't have to go through the working too much, because what you should notice, if we substitute it into our y values, when we square everything, the negative is going to disappear. So the y coordinate there is just going to be 4 again. So we are going to end up with another coordinate, negative a quarter, comma, 4. So those are the two coordinates for our two stationary points. All right, then we're in part B of this question. The stationary points have got the same nature. We want to use the second derivative test to determine whether or not they are maximum points or minimum points. Okay, what's the second derivative test? Well, basically, if y double prime is positive, then what we have is a minimum point. And if y double prime is negative, then what we have is a maximum point. So we're going to differentiate our function again, and we're going to find out whether or not we've got a positive or a negative at the coordinates for our stationary points. So let's just go back. We want to find out what dy dx was again. Where did we find dy dx? Somewhere up here. We had 64x minus 1 upon 4x cubed, or a quarter x to the power negative 3. So let's just write it down. So our y prime was equal to 64x minus a quarter x to the power negative 3. So we just need to differentiate this thing again. We differentiate again, we're going to get 64 plus 3 quarters x to the power negative 4, which is the same thing as 64 plus 3 upon 4x to the 4. Well, we're told that they've got the same nature, so we don't have to do it for both. So why don't I just substitute when x is equal to a quarter? So when x is equal to a quarter, then what we're going to get is y double prime is equal to 64 plus 3 over 4 times by a quarter to the power of 4. Well, we can just simplify this, I think. So this is 3 over 1 upon 4 to the power of 3, right? Because the 4 cancels off. And basically what I hope you notice is it doesn't actually really matter what this value is. The key thing is that we end up with a positive, okay? And of course, if we end up with a positive, then therefore what we're saying is that this thing must be a minimum, okay? So if we were to key it in, doesn't matter, at the end, what we get is a positive value. And so because we've got a positive value for the second derivative, we know that these are minimum points. Okay, then we're in question 3, which is a factor theorem, remainder theorem style question. We must not use a calculator in bold letters, okay? Part A, we want to show that x plus 3 is a factor of this particular polynomial here. Now, look, we need to know the definition of the factor theorem. Basically, the factor theorem states that if x minus a is a factor of a polynomial, then what that means is that x equals a is a root. And what is a root? Well, a root's basically an x-intercept. So if you substitute it into the polynomial, what you should get is 0 at the end. And it's vice versa, by the way. If we know that x equals a as a root, then we know that x minus a is a factor. So in this particular case, if we want to show that x plus 3 is a factor, that's the same thing as showing that x equals minus 3 is a root, right? And how can we show that x equals minus 3 is a root? Well, we can just substitute it into our polynomial. So if we do that, we're going to get minus 12 plus 23 times by negative 3, 23 times by negative 3, plus 3 times by negative 3 squared, minus 2 times by negative 3 all cubed. Well, I'll try to punch through that. So we get minus 12. 23 times by negative 3 is going to be minus 69. Negative 3 squared is 9, times by 3 is 27. And negative 3 cubed is negative 27, times by negative 2 is positive 54. Okay, well, if we put all of that into a calculator, so we get negative 12 minus 69, so that is equal to 81, okay? And then, or negative 81 rather, and then 27 plus 54 is equal to 81, so we get negative 81 plus 81, so that's equal to 0. And so therefore, because that's the case, we have shown that x minus 3 is a root. And because x minus 3 is a root, we have also shown that x plus 3 is a factor. Okay, I know it's probably simple. It's only worth 1 mark, but I thought I'd just explain it anyway a bit more clearly. Okay, so we've got the curve y equals minus 5 plus 33x plus 3x squared minus 2x cubed. And the line y equals 10x plus 7 intersect at 3 points A, B, and C. These points are such that the coordinate A is the least value and the coordinate C is the greatest value. We want to show that B is the midpoint of AC. All right, well, if we want to find the intersection of this and this, then we're solving simultaneous equations, so we need to set these equal to each other. So minus 5 plus 33x plus 3x squared minus 2x cubed is equal to 10x plus 7. And we're going to subtract 10x plus 7 from both sides. If we subtract 7, we get negative 12 here. If we subtract 10x, we get plus 23x. And we get plus 3x squared minus 2x cubed is equal to 0. And lo and behold, surprises of surprises, this polynomial that we get here is exactly the same polynomial as the one in question A. How shocking is that? Of course, that's not at all shocking. That should be what we expect, right? If you don't get the same polynomial as in question A, then you've probably gone wrong somewhere, okay? All right, then, what we want to do is we want to solve this polynomial, and so we want to be factorizing it. Well, we actually already know that x plus 3 is a factor of this polynomial, don't we? So we can use that information. Before we use it, however, I think it's probably just easier just to turn this polynomial into a positive cubic. And the way I'm going to do that is going to multiply everything through by negative 1. I'm going to get 2x cubed minus 3x squared minus 23x plus 12 is equal to 0. I think just make our life a bit easier, turn that into a positive. Well, now, if we know that x plus 3 is a factor, then what we can do is we can do a bit of polynomial division here. So we're going to do 2x cubed minus 3x squared minus 23x plus 12. We're going to divide this whole thing through by x plus 3. Was it x plus 3? Just let me check. Yeah, x plus 3. All right, then let's do a bit of recap of how we do polynomial division. This thing here, right, at the start is always called our leading term. We do the leading term divided by this thing here, right? So 2x cubed divided by x is 2x squared. We then take that 2x squared, and we multiply it by this whole thing here. And what we'll get is 2x cubed plus 6x squared. Now, having done that, we will then subtract off. So 2x cubed minus 2x cubed is 0, which is what we want. Minus 3x squared minus 6x squared is minus 9x squared. Minus 23x plus 12. Well, then, minus 9x squared is our new leading term, so we're going to take that, we're going to divide it by x. If we do that, we get negative 9x. Again, we take the negative 9x, we multiply it through by this thing here. We get minus 9x squared minus 27x, subtract it off. So minus 9x squared minus 9x squared is 0, right? then minus 23x minus 27x is actually plus 27x. So we get here 4x plus 12, right? People will struggle with the negative signs, okay? All right then, well, if that's the case, 4x is now our new leading term. So we're going to do that divided by x. So 4x divided by x is just 4, okay? And so we take 4, we multiply it by x plus 3, which gives us 4x plus 12. And of course, if we subtract it off, we get 0, which is what we should expect. If you do not get 0, and you know that x plus 3 is a factor, then you have gone wrong. Okay, now then, what does this mean? It means that we can rewrite our polynomial, p of x, as being equal to this thing, x plus 3, times by this thing here. Now, if you're not sure about that, just take a moment and just think it through. What we've said is if we divide our polynomial, this thing, by x plus 3, then what I'm going to get is this thing here, this quadratic, right? So this divided by this, me that. Well, therefore, if I just multiply both sides by x plus 3, what I'm saying is that this thing, our polynomial, must be equal to x plus 3 times by the quadratic. We're just rearranging, basically. So p of x is equal to x plus 3 times by this whole quadratic, which was 2x squared minus 9x plus 4. So 2x squared minus 9x plus 4. All right, then. So we've now got this quadratic factor. Well, we should probably try to factorize that. So let's do that. We're going to have a 2x term here. We're going to have an x term here. And we're looking for two numbers. They're going to multiply together to give positive 4, and they're going to combine in such a way that we get negative 9. Well, I think that's going to look like we're going to get negative 4 here, and oh, are we going to get negative 4? Negative 4 and positive 1? Sorry, negative 4 and negative 1, beg your pardon. Yeah, negative 4 and negative 1, because if we get negative 1 times negative 4, we get positive 4. And then we get 2x times by negative 4, we get negative 8x, and negative 1 times by x is negative x. So negative 8x minus x is minus 9x. Do beg your pardon there. Okay, well, what does this mean? Well, the solutions to this polynomial are when this whole thing is equal to 0. So we've then got roots. Okay. We can say we get roots by saying x plus 3 is equal to 0, or 2x minus 1 is equal to 0, or x minus 4 is equal to 0, which means that our roots are going to be x is equal to negative 3, x is equal to positive 1/2, and x is equal to 4, right? So those are the three x coordinates of our intersections. Let's just go back and read the question. We want to show that B is the midpoint of AC. All right, well, we probably want to find the y coordinates as well. Now, y is equal to 10x plus 7. Right, y is equal to 10x plus 7. So let's find the y coordinates. Okay, so right up here, y is equal to 10x plus 7. So the y coordinates are going to be found by multiplying our x coordinate by 10 and adding 7. So negative 3 times by 10 is negative 30, plus 7 is negative 23. The y coordinate is equal to negative 3. 1/2 times by 10 is 5, plus 7 is 12. And 4 times by 10 is 40, plus 7 is 47. That means that we have got three coordinates, okay, and those coordinates are negative 3, negative 23, and 1/2, 12, and 4, 47. And of course, this is going to be A, B, and C. Okay, then, well then, what's the last step? Well, we want to show that B is the midpoint of A and C. So why don't we just find the midpoint of A and C? So the midpoint of A and C. And how we do that is that we add up the two x coordinates and we divide by 2. So we're going to get negative 3 plus 4 divided by 2. I'm going to do the same thing with the y coordinates. I'm going to do minus 23 plus 47 and divide by 2. So minus 23 plus 47, and we divide through by 2. If we do that, minus 3 plus 4 is 1, divided by 2 is 1/2. Minus 23 plus 47 is 24, and 24 divided by 2 is 12. And so that thing there is the same thing as the coordinate of B, And so we have shown that the midpoint of AC is the same as the coordinates of B. All right, here we are in question 4, which is a connected rates of change style of question. We've got the variables x and y are related by this particular equation, where x is between 0 and pi by 2. And we're given that x is increasing at a constant rate of 0.04 radians per second, and we want to find the corresponding rate of change of y when y is equal to 3. Now, with these kind of questions, I think it's important that we identify and label information from the question at the very start. So what does this thing here mean? X is increasing at a constant rate of 0.04 radians per second. What does that represent? Well, that is the rate of change of x with respect to time. We can write that as dx dt, right? dx dt literally means the change of x with respect to the change of t, the change of time. Another clue for that, if you're not entirely sure, is that this is radians per second, isn't it? So what we're dealing with is a change per unit time, dt. Okay, so we can label dx dt as being 0.04. Okay, then, well, what are we being asked to find? We want to find the corresponding rate of change of y when y is equal to 3. Now, it doesn't say the rate of change of y with respect to time, but that is implied and should be clear. So we are trying to find dy dt. And then what we want to discover is, well, what's the relationship between dx dt and dy dt? And in order to get that, we need a chain rule. So we can say that dy dt is equal to dy dx times by dx dt. Okay? In other words, we can find dy dt by taking our dx dt and multiplying it by dy dx. Now, if you're not sure how to arrive at this particular equation here, then basically what you need to do is you need to try to think of these two things as fractions. Not really fractions, strictly speaking, but it's a very convenient way to think about it. Because if we were to multiply these two fractions, what would we get? Well, the dx's would cancel out. And if the dx's cancel out, then what we're left with is dy dt, which is the thing we want here on the left-hand side. Okay, so what you're really trying to do is you're trying to create a kind of equation like this, such that the variable that you don't want is being cancelled off. All right? Okay, then. So we want to find dy dt. We've got dx dt. So the thing that we need is we need dy dx. Well, how are we going to get dy dx? Well, we've got to differentiate this thing here with respect to x. So I'm going to write that down. So we've got y is equal to 2 plus tan 1 minus x. So we've got to differentiate this thing with respect to x. So dy dx. If I differentiate 2, I get 0. If I differentiate tan, I get sec squared. I get sec squared 1 minus x. But remember, this is a chain rule, isn't it? I've got a function inside a function. So the function on the inside here is 1 minus x. So if I differentiate that, I get negative 1. So I've got to remember to multiply by negative 1 here. Okay, so we get minus sec squared 1 minus x. Well, all right. The question says we are interested in finding the rate of change of y when y is equal to 3. Well, that's going to be a little bit awkward, isn't it? Because we can't substitute y is equal to 3 into here because this is an x value. So what we need to do is we need to find out what the value of x is when y is equal to 3. In order to do that, what we've got to do is we've got to substitute our y is equal to 3 into here, rearrange to find x. That's what I'm going to do. Okay, so I'm going to go down here and I'm going to say when y is equal to 3, and we're going to get 3 is equal to 2 plus tan 1 minus x. So you see what I've done is I've substituted into this equation here. Okay, and so therefore 1 is equal to tan 1 minus x. And so we do the tan inverse of both sides. Now, hopefully you know that the tan inverse of 1 is pi by 4, but you can use your calculator. Remember, if you're using your calculator, you need to have it set to radians for this question. Okay? The reason for that, by the way, is that differentiation and integration only work with radians. right? So you can't use degrees at all. That's for technical reasons. It also means that if you write here, for example, by mistake, 45 degrees, then obviously you're going to get the wrong answer in the end, and everything else is going to be a bit screwy. Okay, so you need to use your radians. All right. So x is going to equal to 1 minus pi by 4. Okay, so we've got that there. All right, so now we've got our x, so we can substitute it into our dy dx term up here. All right, so let's do that. So remember that dy dx was equal to minus sec squared 1 minus x. So we're going to say when x is equal to 1 minus pi by 4, then what we're going to get here is dy dx is equal to minus sec squared 1 minus 1 minus pi by 4. Now, I know I'm doing a little bit overkill here, but I think you always want to be careful about trying to do things too quickly, too cleverly, because you're only human. You end up making mistakes, right? So we're going to get 1 minus 1 is 0, and then minus pi by 4 is pi by 4. Okie dokie. Well, what does sec mean? As always, with these, with cosec, sec, and cot, we want to look at the third letter. So first letter, second letter, third letter. Third letter is C. That means that sec is 1 divided by cos. So really what we've got here is minus 1 over cos squared pi by 4. Okay? And again, you can use your calculator. You've got to remember your calculator needs to be set to radians. And cos of pi by 4 is root 2 upon 2, or 1 upon root 2. So we get 1 upon root 2 there. We square that. So 1 upon root 2 squared is 1 upon 2. And if we've got 1 divided by 1 upon 2, that's the same as 2. In the end, our dy dx is equal to negative 2. Well, okay then, we just got to return back to our original equation connecting the rates of change. We said that dy dt is equal to dy dx times by dx dt. And we now know that dy dx is equal to negative 2 when y is equal to 3. We're going to go up here. What was our dx dt? Our dx dt was 0.04. We go all the way down here. We're going to times this through by 0.04, and that gives us minus 0.08. Okay, so the change in y with respect to time is minus 0.08 radians per second. Okay. All right, guys, I hope that that was helpful. Okay, so we're now in question 5. We've got the variables p and t are known to be connected by the relationship p is equal to ab to the power t, where a and b are constants. And the values of p are found for certain values of time t. We want to show that the graph of log p against t will be a straight line. All right, then what we're going to do is we're going to start with p is equal to a times b to the power of t. And what we always do basically is we log both sides. So I'm going to find the log of p is equal to the log of a times by b to the power of t. Now, in order to do this, what we've got to know is we've got to know our log rules. Okay, so we've got the first log rule is the log of a plus the log of b is equal to the log of a times b. And then we've got the second log rule, which I don't think we're using in this question, but I'll state it anyway. The log of a minus the log of b is equal to the log of a divided by b. Okay, and then lastly, rule number 3, if I've got the log of a to the power of p, then that is equal to p times by log a, right? These are the 3 rules. So we can use the first rule on this thing here, right? Because I can rewrite this as the log of a plus the log of b to the power of t. And then once I've done that, I can use the third log rule on this thing here, and I can rewrite this as t times by log b. Okay, so what we end up with is the log of p is equal to log a plus t log b. Now, it's important to identify here what are our variables and what are our constants. Okay, so variables are p, right? So this whole thing here is going to be a variable, and t is also a variable here. log A is going to be a constant because A is a constant, and log B is going to be a constant because B is a constant. So if I just rewrite this in a slightly different order, what we've got here is log P is equal to log B times by T plus log A. What I'm hoping that you can see is that this thing is actually a y equals mx plus c equation, right? Because log p is going to be our variable y. Log b is a constant, right? So that will be our gradient m. T is our variable, our second variable, so we call that x. And log a is also a constant, and so that will be our y-intercept c. So basically what we've shown is that the graph of log p against t, right, because we've got this thing against this, will be a straight line. Okay? All right then. Let's go to part B. So the diagram shows that the graph of log p against t, the graph passes through the points 0, 6, so that's there, and 14, 12, that's there. We want to find the values of a and b. Well, earlier, what we got is we got that the y-intercept of this graph is going to be equal to log a. So if we find the y-intercept on the graph, which is this, right, that will be equal to log a. And then we said that the gradient of this graph would be equal to log b. So if we find the gradient of this graph, we know that it will be equal to log b. So why don't we just do that? So we have said that let me just go up again, the y-intercept is log a. Okay, so we can immediately write down, right, that the y-intercept, which is 6, is going to be equal to log a. And log here is log base 10, right? That's what LG means. LG is just a very lazy way of writing log base 10. So we can say that A is equal to 10 to the power of 6, which is a million. Okay, so that's A. Well, we need to find the gradient of this graph, right? So why don't we just do that? M is going to equal to y2 minus y1, so that's 12 minus 6, over x2 minus x1, so that's 14 minus 0. We end up there with 6 upon 14, which is 3 upon 7. There we get 3 upon 7. Okay, well, if we've got 3 upon 7, then we said earlier that the gradient is equal to log b, right? That's this thing here. So gradient is equal to log b. So we can go down and we say, all right, well then, we know that log b is equal to 3 upon 7. And again, this is log base 10, so we can write that b is equal to 10 to the power of 3/7. Okay, so we should probably just finally write down our relationship, right? Remember that we were told that p is equal to ab to the power of t, so that's what we're going to write down. We're going to write that p is equal to 10 to the power of 6, times by b, which is 10 to the power of 3/7 to the power of t. Okay, and that is our answer. Okay, part C of this question. Using the graph or otherwise, find the length of time for which p is between 100 million and 1,000 million. Well, what we've got is we've got a graph of log p against t, right? So it's probably good if we log both of these values. So if p is equal to 100 million, that's 100 times by 10 to the 6, and that's going to be equal to 10 to the power 8, right? Because 100 is 10 to the power 2, times by 10 to the power 6 is 10 to the 8. And when p is equal to 1,000 million, well, we just times it up by 10. That's equal to 10 to the power of 9. So if we log both of these, right, if we find log p, then we've got log of 10 to the 8, which is just 8. So let me just rewrite that actually. So log 10 to the 8 is just 8. And here what we got is log 10 to the 9. Okay, and that's going to be equal to just 9. So on our graph, what we want to find is where log p is equal to 8 and where log p is equal to 9. So let's just go up to that graph. And let's try to draw some straight lines that go across. So here is 8. So we're going to go across to there. And I'll take that down to here, I think. Something like that. And 9 is going to be like roughly there. Okay, maybe to there. And we'll go down to here like that. Okay. So if I then read off the values of time on the bottom, then what I can see is, well, that looks to me like 4.8, I think. And this value here looks to me roughly like 7. Now, it may be, you know, because I'm doing it on a screen, right? So it may not be totally accurate, but it looks roughly right to me. So then what's the difference in time between these two values? Well, 7 minus 4.8 is 2.2. So I would think that 2.2 is probably good enough. I'm just going to very quickly check the mark scheme. Mark scheme gives you a range between 2.2 and 2.4. So you want to try to be a little bit accurate, guys. That is important. But the essential method is there. Okay, hope that was helpful. Okay, so we're in question 6, a binomial expansion style question. We want to find the first 3 terms of this expansion here in ascending powers of x, and we want to simplify the coefficient of each term. Okay, well, this should hopefully be relatively straightforward. We've got 1 plus x over 7 to the power of 5. Now, the way I write out binomial expansions is like this. I take the first term here, which is in this case 1, and I know that I'm going to have 1 to the power of 5, and then another term with 1 to the power of 4, and then another term with 1 to the power of 3. In other words, what I've got is I've got decreasing powers here. So 5, 4, 3. Then I've got the next term, which is x to the power of 7. So x to the power of 7. And this is going to have increasing power. So to the power of 0, x upon 7 to the power of 1, and then x upon 7 to the power of 2. So just following that, the second term's got increasing powers, 0, 1, 2. And then lastly, we've got to have the coefficient. So we're going to have 5c, 5c, 5c. And of course, what happens is that increases. We go from 5c0, 5c1, 5c2. And of course, we add up all these terms. Now, that may seem like a bit of an odd way of doing it, but just in my experience, right, we're all human. What happens is if we try to write out this thing here, right, 5c0, 1 to the power of 5, x upon 7 to the power of 0, and we keep on doing it. It's so easy just to make a tiny, tiny mistake. The tiny mistake can actually cost you quite a lot of marks. So what I suggest you do is you kind of think of it nice and systematically, right? So we've got this thing here where the powers decrease by 1, and the powers here increase by 1. And then we've got 5c, and then this increases by 1, 2. So 0, 1, 2. And after you've written it all out, just double check it as well. It's better to check early and not make a mistake than make a mistake and then have to spend 10 minutes figuring it out. Okay, well, let's simplify all of this. So we've got 5c0, which is 1. 1 to the power of 5 is 1. And x upon 7 to the power of 0 is 1, because anything to the power of 0 is 1. Then we've got 5c1, which is 5, times by 1 to the power of 4, which is 1, times by x upon 7 to the power of 1, which is just x upon 7. Then what we're going to have is 5c2 is 10, times by 1 to the power of 3, which is 1, and then times by x upon 7 squared, which is x squared upon 49. And of course, we've got other terms, but we're not interested in them. Well, let's just tidy this up. 1 times 1 times 1 is 1, plus 5 upon 7x, plus 10 upon 49, x squared, plus dot, dot, dot. All right, then. Then let's try part B. The expansion of 7 bracket 1 plus x to the power of n times by 1 plus x upon 7 to the power of 5, where n is a positive integer, is written in ascending powers of x. The first 2 terms of the expansion are 7 plus 89x. Find the value of n. Well, look, our terms finish at x to the power of 1. So we're not really interested in anything beyond that. We're not interested in x squared. So what we're going to do is we're going to firstly take the expansion of 1 plus x to the power of n, and we're going to find the first 2 terms of that. We do it in the same way, right? So we're going to get n c0, 1 to the power of n, x to the power of 0, plus nc1, 1 to the power of n minus 1, x to the power of 1. We've got other terms there as well, dot, 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 dot. But nc0 is 1, 1 to the power of n is 1, and x to the power of 0 is 1. So this term is just 1. nc1 is n. Right, you can check that on a calculator, by the way, right? If you do 4c1, you'll get 4, 5c1 is 5, 6c1 is 6, and so on. So nc1 is n. Then 1 to the power of n minus 1 is 1 times by x. So we're left with that and all the other terms we're not interested in. And then we saw that 1 plus x upon 7 to the power of 5, that had terms 1 plus, let me just double check it, make sure I get it right, 5 upon 7x. Okay? 5 upon 7x plus dot, dot, dot. So really what we're being asked to do in the expansion is we're being asked to do 7 times by 1 plus nx plus lots of other terms we don't care about, times by 1 plus 5 upon 7x plus lots of other terms that we don't care about. Now then, if we were to expand this thing here, what's going to happen? Well, we can think of it in terms of the constant term and the x term. The way we're going to get a constant term is we're going to get the 1 times by the 1, which is 1, times by 7, right? So our constant term there should just be equal to 7, which is exactly what we're told there, right? That thing is 7. But what about the x term? And the x term we're told is going to be equal to 89. How are we going to get x? Well, either we're going to have 1 times by 5 upon 7, or we're going to have n times by 1, right? Those are the two ways that we can get a coefficient of x. So the x term is going to be equal to the 1 times by 5 upon 7, so 1 times by 5 upon 7, and also the n times by 1, right? So we're going to get this times by that, or and also this times by that. And of course, we've got to remember we've got to multiply that all by 7. Well, this whole thing times by 7 is equal to, what are we told it's equal to? It's equal to 89. Okay. All right then. Well, I think we can just we can simplify this. Hopefully, I'm going to expand this top bracket here. So 7 times by 5 upon 7 is just 5, plus 7n is equal to 89, which means that 7n is equal to 84. And then we divide through by 7, we're going to get n is equal to 12. So our answer there should just be n is equal to 12. Okay, guys, here we are in part B of this question. In the expansion of k minus 2x to the power 8, where k is a constant, the coefficient of x to the 4 divided by the coefficient of x squared is 5 upon 8. The coefficient of x is positive. Form an equation, hence find the value of k. Right now, here you've got a big complex question. And the way you do a complex question is you always break it down into smaller questions. So firstly, what we're going to do is we want to find an expression for the coefficient of x to the 4, and also an expression for the coefficient of x squared. That's how we're going to start. Now, how are we going to handle this? Well, basically, we want to realize that if we've got the expansion of k minus 2x to the power of 8, we want to try to figure out what each term looks like. Now, hang on, just before I do that, by the way, instead of thinking about k minus 2x, I think it's often quite helpful to think of this as k plus minus 2x. Actually, I think that will help some of you with this idea of expanding. Okay, now in this particular case, what's each term going to look like? Each term is going to have a k to some power and a negative 2x to another power. And then it's going to have a coefficient, which is going to be 8c something, right? So each term of the expansion is going to look something like that. Now, what do we know about these two powers? Well, this power and this power, they must add up to give 8, right? So that's the first condition. And then this term here in the NCR constant, well, that can be either this thing or this thing, right? It doesn't really matter. Okay, so we know that each term is going to look something like this. And that means that we should be able to find out the x to the power of 4 term and the x to the power of 2 term. So let's do the x to the power of 4 term first. Okay, so what I'm saying is that's going to look like 8c something, k to the power of something, negative 2x to the power of something. Well, if we want x to the power of 4, this power needs to be 4, which means that that power there needs to be 4, right? Because the two things have got to add up to give 4. And then the 8c something term, that can be either this or this, but both are the same, both are 4. So let's expand this. Okay, we're going to expand this, and we should get 8c4. So 8c4 is 70 times by k to the power of 4. Now, minus 2x to the power of 4, that's going to give us 16x to the power of 4. Now, I'm just going to leave it like that. I'm not going to bother to expand it because hopefully things are going to simplify later on. Okay, now we're going to find our x squared term. We're going to do that in exactly the same way. Okay, so if we do our expansion, what we should get is 8c something, k to the power of something, negative 2x to the power of something. Well, we want an x squared, don't we? So that means that this power here has got to be 2. And if that power is 2, this one's got to be 6, because the two powers have got to add up to give 8. And then the thing that goes here, that can be either 2 or 6, really doesn't matter. I'm going to choose 2. Okay, so now let's try to go through the expansion. We've got 8c2 is 28, k to the power of 6, negative 2 to the power of 2 is 4, and so we're going to get there 28, k to the power of 6, 4x squared. Now, we are told in the question that the coefficient of x to the 4 divided by the coefficient of x squared is 5 upon 8. Well then, what's the coefficient of x to the 4? It's this thing here, right? So let's write that down. We have got 70 times by k to the power of 4 times by 16. That's the coefficient of x to the 4, divided by the coefficient of x squared, which is 28 k to the power of 6 times by 4. That's going to be equal to 5 upon 8. Well, now, hopefully you can see the wisdom of not expanding earlier, because things are going to cancel, right? If I do 16 over 4, that's going to cancel just to give me 4 there. And 70 and 28, they're both divisible by 7, aren't they? So that gives me 10 over 4. Okay, so why don't I simplify this out? So I'm going to get 10 k to the power of 4 times by 4 over 4k to the power of 6 is equal to 5 upon 8. And hopefully you can see I can also cancel the powers of k. So if I divide top and bottom by k to the power of 4, then on the bottom I'm going to get k squared. So in the end, what am I going to get? I'm going to get, well, I can also cancel off the 4, can't I? Cancel off that 4 there. Okay, so I'm going to get 10 upon k squared is equal to 5 upon 8. If I multiply through, whoops, sorry about that, k squared is going to be equal to 8 times by 10 all upon 5, which is the same thing as 16, right? Because 10 divided by 5 is 2, and 8 times by 2 is 16. So if k squared is 16, then k is either equal to plus or minus 4, but we are told in the question that that the coefficient of x is positive, right? The coefficient of x is positive. We need to just be really, really, really careful here, okay? We want to consider what the coefficient of x term would be. So we have got k plus minus 2x to the power 8. So k plus minus 2x, I beg your pardon, minus 2x to the power of 8. We want to ask ourselves, well, what's the expression with the x term in? Well, we're going to have negative 2x here to some power, k to another power, and then 8c something. Well, if we want a coefficient of x, then this power is going to be 1. That is going to be 7. And this thing here, we'll call it 1. Well, let's just expand that. Sorry, it's the x term, isn't it? What we get is 8c1 is 8. We would get k to the power of 7, and we would get minus 2x. Okay, now that means we're going to get minus 16 k to the power of 7 times by x. Now, we want this coefficient to be a negative number. Now, if this is going to be a negative number, then that means that this thing here needs to be a positive number, right? Because a positive times by a negative is a negative. That means that k would have to be equal to positive 4. Okay, so I just want you to be super careful with that, right? There's a kind of a little sting in the tail there. You want to, oh wait, hang on. Let me just read the question again, actually, make sure I got it right. Sorry, beg your pardon. The coefficient of x is positive. Coefficient of x is positive. And therefore, because the coefficient of x is positive, sorry, I misread the question, then what we require is that this thing here is negative, right? Because a negative times a negative is a positive. So if k to the power of 7 is negative, then that means that actually the k must be equal to negative 4, right? So that's the sting in the tail, right? We need to be super careful about that, because I think what would happen is a lot of people get to the end of this question and they would say, probably k is plus or minus 4, it'll be plus 4, but it's not, okay? The value of k is negative because that ensures that the coefficient of x is positive. So that's a really nasty little trick that they've put in at the end there, but I hope that you can see how we've been able to do that. Okay, then here we are in question 7, part A. We've got a function f of x, which is defined as this thing. We want to find an expression for f prime x, giving our answer as a simplified algebraic fraction. Now, this thing looks extremely complicated, but really is what it is a chain rule within a chain rule. Okay. Now, when do we use the chain rule? We use a chain rule when we've got one function inside of another function. So let me try to explain that here. What we've got is we've got the function 4x minus 2, and that's inside the function x to the power of 5, right? And then we've got this whole function here, the 3 plus the bracket to the power of 5, and that is inside another function, which is a square root. Okay, so we've got a function inside another function. And whenever we've got that situation, we need to use the chain rule. Now, I think probably the best thing for me to do is I'm just going to do it, and then I'm going to try to explain a little bit afterwards. So first of all, I'm going to start actually by writing f of x in indices form. So f of x is 3 plus 4x minus 2 to the power of 5, all to the power of a half. So then what I'm going to do is I'm going to differentiate the big bracket first. So I'm going to differentiate the big function on the outside. And if I do that, I'm going to get a half big bracket to the power of minus a half. And everything inside the bracket remains the same. And then what I've got to do is I've got to take this thing inside the bracket and I've got to differentiate that. So if I differentiate 3 plus this whole thing, well, the 3 differentiates to give 0. And this whole thing, well, if I differentiate that bracket, what I'm going to get is 5 bracket 4x minus 2 to the power of 4. That's differentiating the bracket. Then I've got to differentiate this 4x minus 2. I get 4. And so I multiply through by 4. So now if I was to multiply this whole thing, I've got 5 times by 4, which is 20, divided by 2, which is 10. I've got 10 bracket 4x minus 2 to the power of 4, and then all divided through by the square root of 3 plus 4x minus 2 to the power of 5, right? Because that's what the power of negative a half means, right? The half means square root. The negative means 1 over. Now, for those of you who are finding that a bit complicated, I want to spend a bit of time just explaining this whole chain rule idea. So if you want, you can just skip this bit. But for those of you who are interested, I think it's maybe helpful. Let's say we've got a function y is equal to 5x squared plus 2 to the power of 10. What I want you to understand is we've got one function, which is 5x squared plus 2, inside of another function, which is x to the power of 10, right? This is like a composite function. So I'll call the function on the inside, that's in red. The kind of the function that it's inside of is the thing in green, right? So you're inner function, outer function. Now, the way we differentiate this is we differentiate the outer function first. So we're going to get 10 bracket to the power of 9. And then what we're going to do is we're going to differentiate the function on the inside, the red thing, and that's going to give us 10x. So we multiply by 10x. Okay, let's try another example. This time let's try y is equal to the square root of 3 plus 7x cubed. Okay? Now if we do this, we've got one function, which is 3 plus 7x cubed, which is inside of another function, which is the square root. Let me just rewrite that in a way that's a bit better. We've got here 3 plus 7x cubed to the power of a half. So our function on the inside is that thing, and our function on the outside is that thing. So what we're going to do is we're going to differentiate the function on the outside first. So we get a half bracket to the power of minus a half. And then we're going to, so we still get 3 plus 7x cubed there. Then we differentiate the function on the inside. We differentiate the red thing, and we're going to get 21x squared. Okay? All right, then let's try one more. Let's say we have got y is equal to sine, I don't know, 5x to the power of 2 minus 3x. Well, here we've got one function, which is the 5x squared minus 3x, inside of the other function, which is the sine. So how do we differentiate this? Well, we differentiate the big function on the outside first. So sine differentiates to give cos. We get cos 5x squared minus 3x. Then we differentiate the function on the inside. We differentiate the red thing. And what we get is 10x minus 3. And so we multiply through by that. Okay, so really, guys, the big idea is for the chain rule is you got one function inside of another function. How do you do that? Well, you differentiate the big function first. You take the little function, you differentiate that, and you multiply through. Okay, so returning back to our original question, right? What I've done is I differentiate this thing here, this big function, the power of a half. So that means half comes down to the front, power of negative a half. And then what I do is I differentiate this thing on the inside, which means that the 3 differentiates to 0. I differentiate this thing, but then this thing is another function, 4x minus 2, inside of the x to the 5 function. What I do is I differentiate the x to the 5, so 5 comes down to the front, 4 comes here, and then I differentiate the smaller function, and I get 4, and I multiply through by 4. That's quite demanding. I suspect quite a lot of students don't really understand that, right? They kind of memorize rules. But what you kind of want to do is you want to understand what the chain rule is and when it's being used. And the core concept is you use the chain rule when you've got a function inside of another function. Okay, so here we've got question 7b. We've got the variables x and y are related by this particular equation. Using differentiation, find the approximate change in x when y increases from 10 by the small amount 0.01, right? This is an approximate rate of change question. And those kind of questions, you need to know this formula, that delta y over delta x, which is the small change in y divided by the small change in x, is approximately equal to, beg your pardon, approximately equal to dy dx, where dy dx is the tangent to the curve at the point that we're interested in. Well, the point that we're interested in this particular case is when y is equal to 10. And the small increase we've got is in y. So we know that delta y is equal to 0.01. Now, that's a real trap there, because most of these questions, they start with a change of x, but this is a change of y. So delta y there is 0.01, and what we're being asked to find is the approximate change in x, which is delta x. Okay, then, so what do we got to do? Well, firstly, we've got to find, I think, the x coordinate when y is equal to 10. So let's start with that. So we're going to say that when y is equal to 10, we got 10 is equal to 5x over 3x plus 2. So let's multiply through. So we're going to get 30x plus 20 is equal to 5x. And so therefore 25x is equal to negative 20. And so x is equal to minus 4/5. Okay, so that's our first thing. That's the x coordinate that corresponds to y is equal to 10. And then what we want to do is we want to find the equation of our tangent. So we've got to differentiate our function. And notice that this thing here, y, is one function divided by another function. That means we've got to use the quotient rule, right? So we're going to write here, u is equal to 5x, and v is equal to, what was it, 3x plus 2. And so u prime is equal to 5, and v prime is equal to 3. Now, what is the quotient rule? Well, the quotient rule is given by the following formula. V du minus u dv all over v squared. So we're going to substitute in. So our v is 3x plus 2 times by 5. So that's 15x plus 10. Our u dv is 5x times by 3, which is 15x. And our v squared is 3x plus 2 all squared. And you get 3x plus 2 all squared. Well, this is going to simplify, isn't it? Because the 15x and the 15x, they cancel out. So we've got 10 over 3x plus 2 all squared. Well, now we're interested in the coordinate when x is equal to negative 4/5. So let's just substitute that in. When x is equal to negative 4/5, then our dy dx is going to equal to 10 divided by 3 times by negative 4/5, which is minus 12/5 plus 2 all squared. And so if we add that, what we're going to get is 10 divided by negative 2/5 all squared. And so if that simplifies, we're going to get 10 over 4/25. Okay, so this is like 250 divided by 4. Okay, which is, we'll just leave that as it is, I think 125 upon 2. So then what we're going to do is we're going to go back up here. We're going to say, well, we need to use this expression, delta y over delta x is approximately equal to dy dx. Go down here. So delta y over delta x is approximately equal to dy dx. So our delta y is 0.01, 0.01 over delta x. And so that's going to be approximately equal to 125 over 2. What's delta x going to be equal to? Well, delta x is going to be approximately equal to 0.02 divided by 125. Okay? And if we were to sort that out, let me just get my calculator. So 0.02 divided by 125 is 1.6 times by 10 to the power of negative 4. Or if you prefer, 0.00016. Okay? And that's our answer to part B. Okay then, so we're in part C of this differentiation question. We're asked to differentiate x cubed ln x. Now the thing is here, what we've got is we've got one function, which is x cubed, multiplied by another function, which is ln x. In other words, what we've got here is the product of two functions. And if we've got the product of two functions, then we need to use the product rule. So first of all, we're going to call the first function u, so that's going to be x cubed. And the second function v, which is ln x. Then we're going to differentiate both of these. We're going to get 3x squared. And if we differentiate ln, then we're going to get 1 upon x. Now, what's the formula for the product rule? Formula for the product rule is v du plus u dv. And notice I've got it in that order, right? I do v du dx plus u dv dx because I want to keep the same order as the quotient rule so that later on I don't get confused with the order, okay? All right, now I've just got to substitute in. So I've got v times by u prime. So I'm going to have these two things multiplied together. I'm going to get 3x squared times by ln x plus these two things multiplied together, which is x cubed times by 1 upon x. If I've got x cubed times by 1 upon x, I just get x squared. Now, just a quick note, by the way, I want you to see for this thing here, this thing, you can't multiply the x squared into here, right? So in other words, you can't get 3 ln x cubed, right? That's an illegal move. And the reason for that is ln x is a function, right? X is an input into that ln function. It doesn't mean ln times by x, right? So you can't do that. I see that happen a lot. So it's just the reason why I'm flagging it up here, okay? Now I'm going to factorize this. I'm going to factorize out x squared. I get 3 ln x plus 1. Okay, so that's my derivative. All right then, let's have a look at part 2 of this question. Hence, we want to find this particular integral. Now, the key thing here is hence. That means we've got to use our answer from the previous question. We're going to go back up here. Now, what did we learn? We learned that if we were to differentiate x cubed ln x, then what we would get is this thing here, right? X squared bracket 3 ln x plus 1. So therefore, if we were going to integrate this thing, then we would get back to where we started, x cubed ln x. And the reason for that is integration is the reverse of differentiation. So that's where I'm going to start. I'm going to start by saying from part 1 that the integral of x squared bracket 3 ln x plus 1. Now I'm just going to rewrite it in another order. 1 plus 3 ln x. Okay, hopefully you'll see why in a second. dx is equal to x cubed ln x, okay, plus the constant c, right? Because that's really what we saw from the first part of the question. Okay, so now the issue is, well, I want to make this little integral here that I already know look like this thing here, which I'm trying to find out. So what are the similarities? Well, basically everything's almost the same, right? I've got my 3 ln x, I've got my x squared there. There are two differences. One, this is divided by 6, okay? And the second thing is, instead of a 1 here, I've got a 2 there, right? So in other words, I want to change this into a 2. Well, how can I do that? Well, it's kind of like I'm adding x squared, isn't it, right? Because I'm going to have x squared times by this. So what I'm going to do is I'm going to rewrite this as the integral of x squared bracket 2 plus 3 ln x. But then what I'm going to do is I'm going to subtract off another x squared. You see, so that sort of cancels each other out because I've got 2x squared here minus an x squared, which would leave me with the 1x squared. So this integral here is the same as this integral. I've just kind of rearranged it a little bit. Okay, so that's going to be equal to x cubed ln x plus c. And then what I can do is I can split up the integral here on the left-hand side. Right? I can split this up and treat it as the integral of x squared bracket 2 plus 3 ln x dx minus the integral of x squared dx is equal to x cubed ln x plus c. Now then, we can then compute the integral of the x squared, right? We can do this thing. We know how to do that. So we are going to get here the integral of x squared bracket 2 plus 3 ln x dx minus x cubed upon 3 is equal to x cubed ln x plus c. So then I can move this thing across to the right-hand side. So I get the integral of x squared 2 plus 3 ln x dx is equal to x cubed upon 3 plus x cubed ln x plus c. And then lastly, our integral almost looks the same as what we've got, but the only difference now is that there is a division through by 6. So all I've got to do for the last step is I've got to divide the whole thing through by 6. So why don't I do that like this? Divide this by 6. Means I've got to divide everything on the right-hand side by 6. So instead of on 3 there, that becomes upon 18. And this thing here is divided through by 6. And I can leave the constant as is because it's just a constant, right? So constant divided by 6 is the same. All right, guys. That's how we do this type of question. Now, this is one of the more demanding questions of this format that I've seen in recent exams, right? But I think the best place always to start is by reversing what you see in part 1, right? You want to rewrite the thing you differentiated as an integral, okay? If you do that, then if you kind of manipulate your algebra a little bit, what you should get is the answer that you want. But it may take a little bit of time, okay? Hope that was helpful. All right, so here we are in question 8. We've got a curve with equation y equals cos a quarter x, where x is in radians. The normal to this curve at the point where x is equal to 4 pi upon 3 cuts the x-axis at the point P. We want to find the exact coordinates of P. All right then, well, how are we going to find the equation of the normal? How do we find the equation of any straight line for that matter? We need two things. We need a point on our line. We need a coordinate point. And the second thing we need is we need the gradient of the line. If we know these two things, then we are able to find the equation of any straight line. So let's start. How do we get our coordinate point? Well, we already know the x coordinate. So how do we find the y coordinate? Well, we substitute the x coordinate into our equation here. So let's do that. We're going to write when x is equal to 4 pi upon 3, then y is going to equal to cosine a quarter times by 4 pi upon 3. Now, by the way, just so that you're aware, right, when we write x upon 4, I prefer to think of it as a quarter times by x. I think it makes it easier for me to think it through. Okay, then here what we get is the 4s are going to cancel off, so we're going to be left with pi by 3. Pi by 3 is 60 degrees, and cos pi by 3, or cos 60 degrees, is a half. Okay, so what we've got now is we've got the coordinate point, right? We know this. The coordinate point is going to be 4 pi upon 3, comma, a half. Okay, then, well, the next thing we need to do is we need to find the gradient. Well, how do we find the gradient of our tangent? We differentiate. So we've got our curve y equals cos a quarter x. And if we differentiate this, then cos differentiates to give minus sine. We get minus sine a quarter x. And then we differentiate the quarter x. We get a quarter and we multiply through. Now, for those of you who are not sure about that, this is a chain rule, isn't it, right? We've got the quarter x inside of the cosine function, right? So we use the chain rule when we've got a function inside another function. And we differentiate the big function on the outside. So the cos differentiates to give negative sine. And then we look at the function on the inside, this quarter x, we differentiate that, we get a quarter, and so we multiply through by a quarter. Okay, well now we need to find what the gradient is when x is equal to 4 pi upon 3. When x is equal to 4 pi upon 3, y prime is going to be equal to minus a quarter sine a quarter times by 4 pi upon 3. And that's just pi upon 3. Now remember again, pi upon 3 is 60 degrees. And if we know sine 60 degrees is root 3 upon 2, we could also put it in our calculator. Then we've got minus a quarter times by root 3 upon 2. By the way, guys, I strongly recommend that you set your calculator correctly at the beginning of the question, right? If you've got a question that's in radians, set your calculator to radians, because very often what I see is students type in pi by 3, their calculator is set to degrees, and they get a really weird decimal answer, and they spend the rest of the question. If you do get a really weird decimal answer, by the way, usually it means you've done something wrong, as a general rule of thumb. So just something to be aware of. Okay, well, if we get this, then it means that it can simplify to be minus root 3 upon 8. So that means the gradient of the tangent is equal to minus root 3 upon 8, right? Because differentiation tells you the gradient of the tangent. Okay, then, how do we get the gradient of the normal? Well, if two gradients are perpendicular, such as the tangent and the normal, then their product is equal to -1, right? m1, m2 is equal to -1 if those two gradients are perpendicular. So what will be the gradient of our normal? The gradient of our normal will be equal to -1 divided by minus root 3 over 8. And that will simplify to give 8 over root 3. Okay, so that's going to be the gradient of our normal. So if we just go back up a second, we have now got our point and our gradients, right? The gradient of our normal there is 8 upon root 3. So we've got our gradient, we've got our point. How can we find the equation of our line? Well, we can use y minus y1 is equal to mx minus x1. Right? That's going to give us the equation of our line, or in this case, the normal line. We've got to substitute in our point. So we've got y minus a half, because that's the y coordinate of our point. 8 upon root 3 is our gradient. And our x-coordinate was 4 pi upon 3. Okay, so that's the equation of our line. Now, if we read the question, what we're being asked is we want to find the x-intercept of our line. Now, the x-intercept is the place where y is equal to 0. And if you just think about that for a second, if you imagine the x-axis, everywhere on the x-axis, the y-coordinate is 0. When you're being asked to find the x-intercept, what you're really being asked is to find the x-coordinate where the y-coordinate is 0. Okay? So if we set y is equal to 0 here, we're going to get 0 is equal to 0 minus a half is equal to 8 upon root 3 x minus 4 pi upon 3. Now, I suggest that this is the point where you might get a bit too quick. So I'm just going to go a bit slow. I'm going to multiply everything through by root 3 to get rid of this denominator here. If I do that, I get minus a half root 3 is equal to 8 times by x minus 4 pi upon 3. And I will probably multiply everything through by 2 as well, just to get rid of that minus a half. So we get minus root 3 is equal to 16. X minus 4 pi upon 3. Okay, then having done that, I think I'll expand the bracket. So I'm going to get here 16x minus, well, I'm going to get 16 times by 4 pi upon 3. So 16 times by 4, 32, 64. I'm going to get there 64 pi upon 3. And then what I will do is I'm going to rearrange. So I get 16x is equal to 64 pi upon 3 minus root 3. And then what I will do is I'm going to divide both sides through by 16. If I divide both sides through by 16, I get 4 pi upon 3 minus root 3 upon 16. And that will be my answer. But of course, we need to also state the full coordinate. If we state the full coordinate, then we get p 4 pi upon 3 minus root 3 upon 16. The y coordinate is 0. And that there is the final answer. Okay, so here we are in question 9, which is a kinematic style question. A particle travels in a straight line so that t seconds after passing a fixed point, its velocity is given by these equations here. So e to the power of a quarter t when t is between 0 and 4, and 16e upon t squared when t is greater than 4 but less than k. Now, the total distance traveled by the particle between t is equal to 0 and t is equal to k is 13.4 meters. We want to find the value of k. Right. Well, basically what we need to understand for this question is that the displacement of a particle is given by the integral of velocity. And that should kind of make sense, right? Because if you think about it, velocity is the rate of change of displacement with respect to time, right? So velocity is the rate of change of displacement with respect to time. So it's ds dt. So to find velocity, I differentiate displacement. Well, therefore, if I was to integrate velocity, what I would get is displacement, because integration is the reverse of differentiation. Okay, so that's basically the core concept. All right then, so what am I going to do? Well, the first thing I'm going to do is I'm going to integrate the first function. So I'm going to say s is equal to the integral of e to the power a quarter t dt. By the way, guys, I always think it's very helpful, instead of writing t upon 4, write it as a quarter t, right? I think that helps you to understand things more clearly, or it may just be me, but I think it's helpful. If you integrate that, therefore, you get a quarter t, and then you're going to be dividing by a quarter, or dividing by a quarter is the same thing as times by 4. And then you remember that you've got to add the constant of integration there, c. Okay. What we know from the question is that the particle travels in a straight line so that t seconds after passing a fixed point. So what does this mean, this t seconds after passing a fixed point? It means that when you start, when t is equal to 0, you are at your origin point. So s is equal to 0. So this whole statement here, I think it's really, really important to understand. Right, this statement here, what that means is that when, write down, when t is equal to 0, s is equal to 0. Okay, so that's what we're going to do. I'm going to substitute that into here. I'm going to say when t is equal to 0, s is equal to 0. So what I can say is 0 is equal to 4 e to the power of 0 plus c, and e to the power of 0 is 1. So c is equal to -1. Okay, so what we've got here is that the displacement is given by 4e to the power of a quarter t minus, not -1, -4 is what I meant to write there. Beg your pardon, let me just get rid of that. -4. And of course, that's true if t is greater than 0, but it is less than, what was it? Less than 4. Okay? Okay. Well, then that means we should actually be able to find out the displacement when t is equal to 4. So we could say when t is equal to 4, the displacement s is going to be equal to 4e to the power of a quarter times by 4, which is 1 minus 4. The displacement will be 4 bracket e minus 1 at that point. Okay, well now let's consider the second function, the 16e upon t squared. So we're going to integrate that as well. We can say that the displacement is equal to the integral of 16e upon t, upon t squared dt. And we can rewrite that as the integral of 16e times by t to the power of -2 dt. Remember, e is just a constant number, right? So what we can do is we can just treat it as a constant. So we're going to get 16e t to the power of -1 divided by -1 plus another constant, which I'll call k. Okay? All right then, so what I've got here is minus 16e upon t plus k. And we can use another condition, can't we? we can use the condition that when t is equal to 4, that our displacement was equal to, we go back up, 4 bracket e minus 1. Okay, 4 bracket e minus 1. Let's substitute that into here. We can get 4 bracket e minus 1 is equal to minus 16e divided by 4 plus k. And so what we're going to get if we expand is 4e minus 4 is equal to minus 4e plus k. And so k is going to be equal to 8e minus 4. Okay, so therefore we can say that the displacement S is given by the equation negative 16e upon t, negative 16e upon t, plus this thing here, which is 8e minus 4, right? That's our constant there. Okay, so now if we go all the way up, we can say that the total distance traveled by the particle between t is 0 and t is k is 13.4 meters. When s is equal to 30.4, t is equal to k. So let's just put it in here. So when t is equal to k, s will be equal to 13.4. So 13.4 is going to be equal to minus 16e upon k plus 8e minus 4. Okay, so what's the best way of sorting this out? I think let's just rearrange. So I'm going to get 13.4 plus 4 is 17.4 minus 8e is equal to minus 16e upon k. And so therefore k is going to be equal to minus 16e divided by 17.4 minus 8e. Right, and I think what I'll do is I'll try to put that into a calculator. All right, so if I put that all into the calculator, the answer I get is 10.00, so 10.0. And that should be your final answer. Now, okay, guys, I think that was one way of doing this particular question, but personally, I think there is another better, faster way of doing it. If you stick around, what I'm going to do is I'm going to repeat this question a second way using definite integration. All right, so here we are again in question 9. We're going to do this a different way this time. So as I said in the first part, right, the key thing is to understand that displacement is equal to the integral of velocity with respect to time. And the reason for that is kind of the reverse of this, that velocity is the rate of change of displacement with respect to time, right? So if velocity is ds dt, then if you reverse that, if you integrate, then displacement is equal to the integral of v dt. Well, okay, what we've got here is we've got two functions for v. So really what we've got to do is we've got to split up this integral here. So what we're going to say is s is equal to the integral of the first function, which is e to the power of a quarter of t dt, and that's between 0 and 4. And then what we've got is we've got the integral of the second function, which is 16e upon t squared dt, and that's between 4 and k. Okay, so usually what we'd say is, well, s is the integral of our velocity function, and then computed between particular values of t. But because we've got two functions here, what we've got to do is we've kind of got to split up the integral. And so the first part is defined between these two values of time, and the second part is defined between these two values of time. So now let's just do our integration, I think. So first of all, if we integrate e to the power of a quarter t, then that's going to give us e to the power of a quarter t divided by a quarter, which is 4. And we've got to substitute in the bounds of 4 and 0 there. Now, this one, before we even integrate, what we should really do is we should convert this to indices form. We're going to get 16e t to the power of negative 2 dt, and that's computed between 4 and k. Remember, 16e, what that is it's just a constant value, because e ultimately is just a number, okay? And so what we're going to have here is basically the integral of t to the power of -2. Well, if we integrate t to the power of -2, we increase the power by 1, so we get -1, and we divide through by -1. Well, dividing through by -1, same as timesing by -1 there, okay, between k and 4. All right, then, why don't I substitute in my boundaries at this point of time? So firstly, I substitute in the top boundary in the first function, so I get 4e to the power of 1/4 4, which is 4e to the power of 1, minus, substitute in the lower boundary, I get 4e to the power of 0. That's the first one. The second one, let's substitute in our value of k. So I'm going to get minus 16e times by k to the power of -1. Well, that's just 1 over k. Minus, I've got to be a bit careful here. Okay, I substitute in 4, I get minus 16e, 4 to the power of -1, which is dividing by 4, right? Because power of -1 means 1 divided by. All right, then. Now, we know that all of this has got to be equal to 13.4. So 13.4 is going to be equal to 4e to the power of 1, 4e to the power of 0. Now, e to the power of 0 is just equal to 1, so this is minus 4 here. Minus 16e upon k. And then we got minus minus, so we got a positive, and 16 divided by 4 is 4, so we get plus 4e. So here what we're going to get, if I organize things a bit better, is 13.4 is equal to 4e plus 4e is 8e, minus 4 minus 16e upon k. And hopefully you should notice that's basically the same as what we had when I did it previously. So I can now write 16e upon k is equal to 8e minus 17.4. And so therefore k is equal to 16e divided by 8e minus 17.4. And again, if we substitute that into the calculator, what we should get is we should get 10. Now let me just double check that. So I am going to type in 8e minus 17.4. Yep, and then I'm going to do 16e divided by that, and I get 10.01. Okay, so that's my answer there. Now, hopefully you can see that that is a lot less work than the previous way I did it, but I think it's helpful just to do both ways. Good for you to see both. But the key thing here is understanding if I use definite integration, what I can do is I can split up this integral here. Okay, hope that was very helpful, guys. And I'll see you in the next question. All right, then, question 10, which is a vectors style question. We've got a diagram that shows a triangle OAB. The point C is the midpoint of OA. Well, that means that this length here is the same as that length there. The point D lies on CB such that CD to DB is equal to 2 to 3. Okay, so CD is this length here, and DB is that length there, and they've got a ratio of 2 to 3. So I'm also going to label that on, right? 2, 3, okay? We're told that the vector OC is C. So I think I'll probably label that on as well. Let me just put that on. So OC is this thing here. Okay. I'll call that the vector C. And we've got C to B is the vector B. So I'm also going to label that on. C to B is that thing there. I'll call that thing B. Put a line underneath it so we know it's a vector. All right, now the point E lies on AB such that O to E is equal to lambda O to D. Okay, so in other words, to get to E, we just take a scalar multiple of the vector from O to D. And AE is equal to mu AB. So A to E, yeah, again, is a scalar factor of the vector going from A to B. All right. Find two expressions for OE, so the vector going from here to here, okay, such each in terms of B, C, and a scalar, and hence find the ratio of AE to EB. Okay, this question is obviously quite challenging. Now, I find that the thing to focus on is these things here, right, where you see your lambdas and your mu's. So what I'm going to do is I'm going to indicate what lines these represent in highlighter. So firstly, this one here, OE, is equal to lambda OD. So O is representing this line here. Right, so that's that one there. And I'll do in red, AE is equal to mu AB. That represents this line here. So basically what we're going to have to do is we're going to have to use those two lines to find an expression for OE. Okay, so let's start with the yellow one. So we're saying that OE, which is already the thing that we want, is equal to lambda OD. Then the question is, well, okay, how can we find the vector OD? Well, the vector OD is the same thing as going from O to C and then going from C to D. So that's exactly what I'm going to write. I'm going to say that the vector OD is the same as going from O to C and then going from C to D. Okay, well, we already know that the vector OC is just called C, right? Because it's that thing there. But what about this, this vector C to D? How can we write that? Well, we know that the vector C to D is in the same direction as the vector B, but it is 2/5 of that vector. So if I go from here to here, that is 2/5 of going from here to here. Why is that? Well, because this length here is 2, and this whole length here is 2 plus 3, which is 5. I can write down, I can say that the vector C to D is the same thing as 2/5 of the vector C to B. Okay? In other words, it's equal to 2/5 of the vector B. So I'm going to go down here and I'm going to say that this is lambda bracket C plus 2/5 of B. Right, so I've already got an expression for OE there. Now I want to find a different expression for OE, and this time I'm going to use the red line. Okay? So how can I use the red line? Well, what I can say is to go from O to E, I want to use the red line is I go from O to A, and then I go from A to E. Okay, so I'm going to write that down, O to A and then A to E. So the vector OE is the same thing as going from O to A and then from A to E. By the way, your vector equations should always make sense, right? Notice here, right, I'm saying this vector OE, what does it mean? It means I start at O and I go to E. That's what it means. How can I do that? Well, I can start at O and then go to A, and then I can go from A to E, right? So I always start and I end in the same place there. Okay, well, let's go back up. Let's ask ourselves the question, what is OA? Well, the vector OA, right, is going from here to here. So it's going to be 2 lots of going from O to C. So I'm just going to double the vector C. And what I will get is 2C, okay? Okay then, so now what I need to do is I need to find an expression for the vector AE. What's AE? Well, it's along this line AB, isn't it? And we are told in the question that AE is equal to mu times by AB. So I'm just going to substitute that in. So this is equal to mu times by AB. All right, so then now the question is, well, what's the vector AB? How can I go from A to B? Well, what I could do is I could go from A to C, and then I could go from C to B. So let's just write that down over here. The vector AB is the same thing as going from A to C, and then going from C to B. So what's the vector AC? Well, it's going to be the same, isn't it, as the vector C, but it was just going in the opposite direction. So that's going to be negative C here. And what's the vector C to B? Well, we already know that that's defined. That is the vector B. So I can replace AB with minus C plus B. So that's what I'm going to do. So I've got here 2C plus mu minus C plus B. And so that's going to be my second vector, OE. And I think I should probably tidy that up a little bit. I'm going to rewrite that as 2 minus mu times C plus mu times by B. So now notice that what I've got is I've got 2 expressions for OE, right? I've got this expression here, and I got this expression here. And what we can say is these two things are equivalent, right? These two things are the same. And what that means is that the components of C must be the same and the components of B must be the same. So I can now write sort of two equations. So I'm going to be comparing the elements of C. And if I compare the elements of C, then what I'm going to get is I'm going to have lambda C, right, is, I'll just write it as lambda, has got to be equal to 2 minus mu. I can write there 2 minus mu. And if I compare the elements of B, right, then what I've got here, well, I've got lambda times by 2/5. I've got 2/5 lambda is equal to mu. Right then, so what I have here is I've got simultaneous equations. Okay, and what's the best way to do simultaneous equations? Well, probably to do a bit of elimination, isn't it, right? Because I know that, or substitution actually, because I got mu is equal to 2/5 lambda. So what I can do is I can substitute that into here. So I can now write, therefore, lambda is equal to 2 minus 2/5 lambda. And so if I add the 2/5 lambda to the other side, I've got 7/5 lambda is equal to 2, which means that lambda should be equal to 10 upon 7. Okay, 10 upon 7. And if lambda is equal to 10 upon 7, then mu is going to be equal to 2 minus 10 upon 7. Substituting it in, so mu is equal to 2 minus 10 upon 7. Okay, 2 minus 10 upon 7, which is 14 upon 7 minus 10 upon 7, which is 4 upon 7. So we've already got lambda, we've got mu. Just need to ask ourselves what the actual question is asking. We want to hence find the ratio of A to E and E to B. Okay, so A to E and E to B. Well, we know that that's the red line, isn't it, right? So our mu is equal to 4/7. Okay, so what we're really saying is this length here to here is 4/7 of the length from here all the way up to B. Well, another way I could write that is to say that this length here is 4, and that length there is 3, right? Because then that would be 4/7. So our final answer should be that the ratio AE to EB is going to be 4 to 3. Okay? All right, so that's a very complicated question. And with all complicated questions, particularly vectors questions, really the key to it is breaking it down into smaller, simpler things. And I think also a clear diagram helps as well. My final point is, guys, when you're doing these questions, understanding that these two things give you lines that are going to be significant for solving your question. And if you, generally speaking, if you follow those kind of lines, you should be able to work your way towards your answer. Okay, thank you so much. And if you found these videos helpful and that they're helping you through these questions, then please like, please subscribe, please tell your friends. Yeah, I wish you all the best with your studies.